welcome back, everybody. For those of you that are watching us online, hope you're enjoying it. Make sure you use that hashtag #YoungScientist to share with us pictures of your classroom watching today, nice tweets out to all of our finalists. The presentations have been great so far. So let's get on to our next Top Young Scientist finalist for 2016. Our next finalist is Will Paschal from Madison, Georgia. Let's give him a warm welcome. How are you, sir?
I'm doing good. How about you?
Good, good. You ready for this?
Yes, sir.
All right, the lights are on you. Good luck. Have fun.
All right, thank you. Good morning. So a few months back, I was trying to make the world's all-around best battery, and after I got accepted as a finalist, I found that my idea didn't actually work. I spent most of my summer trying to come up with another idea, and during that time, I had the great opportunity of going to Haiti with my dad. It just completely changed my worldview. I'd stepped off the airplane, and it was like I was on a completely different planet. Driving through Port-au-Prince, I saw these long rows of people just sitting on curbs drinking from these little plastic bags of water because they didn't have any in their homes. And one day we went out to eat, and as we were leaving, a small crowd gathered around our car, and in it there was this boy. Now, sweat was just dripping down his face, and he had what looked like a scar covering his cheek, and he approached our car, put his hand on the window, and asked for water. And I could not do anything about it. And to this day, that haunts me. You see, the things we Americans consider commonplace, like AC, electricity, and running water, are seen as impossible and out-of-reach luxuries to the people of Haiti. And that's something I wanted to fix, which is where my hypothesis comes in. I wanted to make a device that could bring light and possibly clean water to the people of Haiti, and I think I have something today that can do just that. Batteries can be quite dangerous under certain conditions, seeing as they utilize many toxic and flammable metals. What I have with me today is a supercapacitor that I've built at home. It's close to rivaling commercial supercapacitors and batteries alike and can be assembled with ease. Now, what is a supercapacitor? A supercapacitor is just a device that, like capacitors, stores energy between two metal plates using static electricity, but it does this incredibly well. It uses a separator material and a solution with many free-floating ions to increase the amount of electricity that it can store without any shorting. That's the basic design of a supercapacitor, just three main parts: the plates, the separator, and the electrolyte. Now, what I've done is I've made cheaper versions of each of these parts with materials that I've found around my house. For the plates, I used a mixture of ground-up activated carbon, which I bought in the fish section in Walmart, and 3-in-1 surface adhesive set onto a small piece of aluminum door screening with copper wire soldered onto it. For the separator, I used a nylon non-woven material that my mentor sent me, and for the electrolyte, I used the most abundant material on the surface of the earth: salt water, not toxic lead or highly flammable lithium salt, salt water. I took each plate and separator and stacked them in a voltaic pile fashion, plates, separators, plates, put them in this little box and filled it up with salt water. And now it's active and ready to be charged. And that's how all these parts come together, to give me this. And it only cost me $4.50 to make. I estimate I could cut that price even lower as I scale up manufacturing and begin to use recycled materials. Another thing is that this could be made into an incredibly easily transportable object, and it could even be assembled by the people using it. For people living near oceans, they could take this thing to the shore, fill it up, and come home with a way to give themselves light. Now, to get here, I actually went through several different designs, each with a slight change, and all leading up to this one, my third and current iteration, still a work in progress. So the third one was actually able to store much more electricity than the last two. On just 3 minutes of charging with a 6-volt battery, I was able to store 1.4 volts and 11 milliamps. That graph is okay. But why am I doing this? Why are we here? Well, what's the point of this project? You see, the thing is, this whole thing that I've been telling you about is not about us or the cool science behind it. It's about them. I've spent the past few minutes explaining to you how this thing I'm holding right here works, but why do we care, really? We care because it can help them. We care not because the thing I'm holding might be very cool in its inner workings, but because it has the potential to one day improve their lives. Maybe only a little bit, but if this device that I hold in my hand could help a child without what I've grown up with do even the smallest of tasks, such as getting water for their families or even completing homework past sunset. If this little box that I hold in my hand could make their lives better, then I think I've achieved my goal. And let me leave you with this. Imagine if that boy with his hand on my car window were your child, desperate for water, and you had the ability to give him one of these, which would allow him to sterilize water and drink it. How do you think that would change his life? Thank you.
Excellent presentation. When it comes to the charging of the capacitors in something like in Haiti, how would that fit into their infrastructure that exists now?
Well, there are actually several different solutions to that problem. There are several different ways, and I know that some of the other finalists actually have solutions to that. So there are very inexpensive ways to generate electricity in developing countries, and I think Hannah's project last year was even about that. But I decided to take a different approach and talk about the storage of that electricity. So that's, thank you.
Great job. I'm very passionate about these issues as well. So
Yeah.
I wanted to ask you, so with the power generated, you're mentioning sterilizing water. Would you use the
Yes.
battery power generated by your device, or would your device do that on its own, or how exactly would that work?
Well, actually, so I was planning on powering a UV LED, which when submersed in water for long enough periods could kill all of the bacteria, rendering it drinkable after you've filtered out all the minerals, which can be done with very inexpensive filters. So that's, thank you.
Will, thanks for an energizing presentation. I do have a question for you about the length of the charge. And
Okay.
essentially, you charge this, and now how long will it remain charged with, for example, one fill of salt water?
Well, actually, I tested this, and I charged it up to 0.85 volts, and I think around 3 milliamps. And it held that charge for 4.5 days until it reached zero. But I have several different design changes in my head that could possibly extend that period, which is known as electrical leakage or just unintentional discharge. And so, yeah, I have several different design changes that could help me make that period longer that it could hold the charge. So, yeah.
Great job. What was the biggest lesson that you learned from your first design that helped you be successful with your final design?
I'm sorry, could you repeat that, please?
What was the biggest lesson that you learned from your first design?
Okay.
That you said that you made several designs.
Okay, yes.
What was
well,
the biggest lesson that
yeah.
you learned from that?
Well, the first one, I actually had not as good connections, and for the separators, I hadn't yet acquired the material that my mentor sent me, so I just used paper towels, and but they worked okay. But as I changed, I found that the connections, good connections, probably helped the most, because if they aren't connected to all of the plates correctly, then, I mean, how are you going to measure a charge? But I think that was probably the biggest change throughout all of those iterations that I went through.
Thank you, Will. I enjoyed your presentation. You certainly have a passion for solving this problem. In your mind, what was the most difficult part of the process, and how did you overcome it?
Well, so are you asking about just the creation of these, just making it, or?
Yes.
Okay. Well, actually, there was a period of time. Oh, excuse me. And this is an example plate here, and to make this, I had to, as I said, mix the activated carbon with the 3M wet surface adhesive. But I put it onto the plate and applied pressure to it overnight, and I think that was the biggest challenge with it, like perfecting that, because that was the most essential part to this. So, yes.
Will, I really enjoyed your presentation. You started out to make a battery. Could you describe the differences in the power you can get from a battery compared to a capacitor?
Well, batteries, you have just AAA, AA, and single A, and they all produce around 1.5 volts, and but then there are batteries like 9-volt batteries. I'm not sure exactly how they vary the voltage in these, but this is actually quite close to producing the same amount of voltage as commercial batteries, and I have several different design changes in my head that would allow me to get and exceed that voltage. So,
about the discharge over time for a capacitor?
Discharge over time. Supercapacitors are actually different than batteries in that when they are being discharged, there's something called a voltage drop, and as you discharge it, the voltage goes down, and once it reaches zero, it's dead, whereas with batteries, it stays constant, but then goes to zero. But you could theoretically change the design of the supercapacitor to limit that voltage drop, so it's, yeah. Thank you.
Were you able to either test or research how much water you could purify or sterilize with a system like this?
Well, okay. All right. All right.
Great job.
Thank you.
Feeling good?
Yeah, I mean, I think I left off a part of it.
It was really good.
Yeah, thank you.
All right, we'll let you get off there. I'll answer
All
that
right,
question
cool.
for you, actually.
Oh, this way?
I'm
All
just
right.
kidding. Let's play a video because I have no idea the answer. So while we get set up, hopefully you're having a good time watching us on the internet here. So want to show you a video from last year that really just talks about the connections and the impact of this between the mentors and the students. So let's take a look at some of last year's finalists and mentors.
Oh my God, I was so excited. I just ran straight through those doors.
I think my favorite part is the moment when the kids walk through the door and you see them for the first time.
It was amazing to meet my mentor today because we've been collaborating all summer long.
The Discovery Education 3M Young Scientist Challenge presents a great opportunity for 3M scientists like myself to interact with students, and so we get a chance to impact the next generation of scientists.
Mentorship is paramount. The scientific process, the process by which we uncover new information and invent new technologies, requires certain skills that virtually no one is born with, but everyone can learn. And the way that we learn it is by working with mentors.
Especially for young people, if they see mentors and work with mentors that help unlock the box of science and they can see what science can really do and how it's related to everyday life, it really gives you a perspective that oftentimes it can be difficult to find on your own.
Having a 3M mentor is just amazing because you can always rely on somebody to help you even if you don't know the solution. So it's always great to have help from somebody else because we don't know everything, we're just kids.
Encouraging students to express their ideas and to share it with others and then to get input and feedback is a critical part of developing scientists.
You really learn about what is science in the real world and how is science actually implemented. You're also getting insight into how 3M approaches science and innovation, how they innovate products that make our lives better.
You need an expert in the field to really teach you what the right things to do are, and I think having a mentor in science is very, very helpful.
My mentor arranged some amazing opportunities for me to meet with experts in my field, which was really cool, and I'm very thankful there for that.
Thank you for all your help. It was really amazing.
I would like to thank her so much because she has really given me inspiration.